Hello, it's Duncan. For the past few episodes, we've been looking at how to deal with errors in Kotlin. But what's better than knowing how to deal with errors? Not having to deal with errors. In this episode, we'll look at how tiny types can remove error handling from most, if not all, of our code. For the past few installments on Gilded Rose, we've been looking at how to handle errors. Now, I promised that we were done with error handling for a while, so this time we're going to look at how to avoid errors. Technically, I think maybe we are going to look at how to move errors around, but often by moving things out of our code base to sort of higher levels, closer to the entry points, then we can have less of our code affected by something, and in particular, errors. So once again, we're going to start at the inside of our app with constructing items. And remember, there are two ways we can fail to create an item. We can fail because we pass in a negative quality, and we can fail because we pass in a blank name. And those are expressed in these subclasses of item creation error. So we've got a negative quality and blank name item creation error. Now, could we arrange it so that you couldn't pass a string that was blank as the name to an item? Because if we could, then one of our errors would go away. The problem is that Kotlin strings are strings and strings can be blank. Now we can imagine subclassing string to give a type of string that could never be blank, adding in a constraint. But we can't do that in Kotlin or Java because string is a final type. It means it can't be extended. What we can do in Kotlin, though, is wrap a string. So we could wrap a string in another class, and that class could ensure that the string inside it was not blank when it was created. What would that look like? Well, if we create ourselves a new Kotlin class and call it non-blank string, then we could have a value inside there. And we could say that when you try and create one of these, that the value is not blank. And if we just made that a data class, then two non-blank strings with banana inside them would compare equal. So we could treat this mostly like a string. In recent versions of Kotlin, though, we've got a better bet, certainly the JVM, and that's to make this a value class. And if we make it a value class and we're forced to say, this is JVM code, then we get a very special type of class, which normally actually just passes around the string. It doesn't create a wrapper object. The compiler remembers that there should be a wrapper, but there isn't really. It's passed around as just the string inside it. So that's quite efficient and it's quite new and shiny. So let's play with it. What we want to do is migrate item to use non-blank string as the type of this name, so that every item's name must be non-blank, but because we gave it a non-blank string, not because we checked when we created one, as we do here. Okay, we'd like to keep all of the code around us running. So what I think we're going to do is we're going to change the type of this name to non-blank string. And we're going to rename it to be name object. Just a different name. But we haven't renamed all the uses, we've just named it in place here. So if we give ourselves a val of name to replace the old one, and say that the value of that is our name object's value. So that is just a string now. Remember, non-blank string has a value of a string inside it. This seems to be the convention with value classes. They can only have one property, and that property, by convention, seems to have the name value. Okay, returning to item, we know the only place we build one of these is in this constructor, this invoke, which isn't really a constructor because this constructor here is private. So this is the only place we have to fix up now. And we can fix this up by creating a wrapper. So we'll create a non-blank string on that name. Now I think that will make everything compile. Let's see whether it runs. We have a problem here with a copy. And we could probably fix that here by saying this is also a non-blank string. Oh, that's also a name object. These little changes will go away. Okay, so we now have failures, and they are these illegal argument exception failed requirement. Why is that? Well, that's because our check that this name is non-blank is now when we create a non-blank string, rather than later on down here where we check the name is blank after we've created the item. So what does that mean to us? Well, it means that if we were to pull this up as a variable, then we could at least try to create our non-blank string. And if that fails with our illegal argument exception, then we know that we can return, or should return, our failure with our blank name. And this is a block. So we will have to make that a block body in order to return from it. Now, it's ugly. Cut that up there and put it in there to make it a little bit nicer. But it passes all the tests except for two that do things with the string. So let's have a look. Here, we were expecting the name to be country banana, but what's actually coming out is, oh, this name object thing. We can fix that reasonably easily now by renaming this to be, say, named string, changing all of its uses everywhere, and renaming this one to be name. And now we're nearly there, but the problem is that toString on a non-blank string gives this string here. That's easy enough to fix. So we'll say that toString is just the value inside us. Okay, so all our tests are passing, which is helpful, but we're in a bit of a mess. So let's return to here and say we're having to catch this exception, to do a try in order to return a failure. But we have a pattern for creating objects that might fail, and that is this companion object with an invoke. So let's go and do that to non-blank string. So we can say we want a companion object. That's going to have a operator fun invoke. That's going to take our value. And in here, we're going to say if value is not blank, return non-blank string, value inside it, else return null. Now, fix up the return type for the return out, make it a single expression, and reformat. Now we are repeating this test here and here in the constructor-like thing and the init. It will be safe to remove the init version, but I'm going to leave it here just to prove a point for a while. Of course, we do want to make the constructor private. Okay, we could write a test on that, but I think it's simple enough not to worry about. Now we can go back to item, and we can say that our name object is now non-blank string name. But note that's now nullable because we're calling the invoke method, the one that can return a nullable non-blank string. So now we have a null, we can just use the Elvis operator to return failure of blank name. Let's try that. Now we have an issue here in our test, but in our test, we don't mind just saying that can't happen with a bang bang. Okay, good. Now we haven't pushed it far, but what we've done is we've pushed the checking that this string is blank from inside our item when we're actually creating one to outside in this constructor function, which isn't actually part of item. We want to do better, of course. What we want to do is pass a non-blank string in here. We'll do that gradually by duplicating this. So if we had a version of this that took a non-blank string, then we could not worry about this malarkey and just pass it in here. That should change nothing, except that this type4 takes a string rather than a non-blank string, so we need to go and get the value in order to pass it a string. Now, having done that, we can implement this one in terms of this one, so that anything that tests this will test this. So what we want to do here is we want to take that name object, and instead of this, we want to say return, not the other invoke, this one here. Now we can go looking for corners of this and replace them one by one. So item test cannot create an item with a blank name. Well, that's an interesting case because, in fact, when we're done, we simply won't be able to create an item with a blank name because we won't be able to create an item with anything that isn't a non-blank string. So I think we can probably just delete this. To item in persistence. Well, this is our production code. And so I think this is the place that we want to migrate to this pattern. I'll come back to that one in a minute. Item tests cannot create items of negative quality. Well, here we can just create a non-blank string in order to make things happy. And as I say, in tests, I don't really mind just asserting that this is not null. We could create a test factory for these. Maybe we'll do that later. And here we're calling the old version, and we can fix that by calling non-blank string on our name. And then, so in our tests where we're usually using literals, we don't mind asserting these are null, throwing exceptions because we'll catch them very quickly. So what are we left with now in callers? Well, we're left with our production code. So let's see how to go and fix that up. What we can do is we can inline this now into our production code. So let's do that. So we're going to inline this here. We replace it with evoke, then we can inline it. Now, apparently there are two occurrences. So let's just do this one for now. I don't know why it thinks there are two. And that seems to have completely failed silently. Let's run our test to check that nothing is seriously broken before we do that by hand. Okay, you can see here that we've got already, for other objects, we are coping with failures before we pass the objects to item. Just reorder this one in order that it's 1, 2, 3. So in this pattern, we'll say val name equals parts 0. And we want a non-blank string from that. And if that is null, now note that previously we've had on failure because we've used an error type. But there's only one way that creating a non-blank string can fail. And so we've just used null instead, null to signify failure. So that makes, again, that we use Elvis. And in this case, we want to return a failure. Now in this case, this is a stock list loading error. And we know that we've got this couldn't create item is the actual type of that. And now we've got our blank name. We're borrowing a blank name for now from inside the item. Now we can put that name into here. And we will be using the other of our factory methods. Let's go and check this one is now unused. And it is, although IntelliJ isn't telling us, so we can delete that and run. Okay, good. Now, the blankness of the string is not item's problem. So item itself never now returns a blank name. So we should be able to delete that and go off to persisting. There's an error here first. Here we've got name string is blank, throw item creation error. So we can get rid of that altogether. That can just never happen. And now we can go back to persisting. Now we don't have an item creation error blank name. So we need to give ourselves a type at this level for that problem. So that should be blank name. And our pattern is that we've given it the whole string. Don't have one of those. IntelliJ might suggest the right place for it. Those all places are wrong because it can only be one of these. So not enough fields. I think it's sort of in the middle here. Data class, blank name. And we want to give it the same things here, which is a stop next loading error. I think that, by the way, is wrong. I think that should be line. Right. Let's see whether that works. Now, I think we had a test. There we are. So this is saying this blank name doesn't exist anymore. What we think our event should now be is not couldn't create item, but it should be blank name with some string inside it. Don't know what the string is going to be yet, so let's just let that fail and tell us what the issue is. And here we have another one before we get there. So this will fail with blank name. And we do know what the string is in this case because we have just used it there. So we changed what happens from a failure to create an item to a failure to parse a name because we got a blank string. And this is that one little place. So this is going to be a string that used to have banana in it and now doesn't. So we'll go here and we'll say that happened because we parsed that string. Okay, so let's review that as we check it in. What we've done is we've created this non-blank string type, which can only be created with a value inside it that is a non-blank string. Now, we have said that item must be created with a non-blank string rather than just a string. And that means that errors in creating that name are pushed up. They're pushed out of constructing an item into constructing a parameter to pass to the construction of item. And that means that the problem actually ends up with persisting, and so it's where we read that we had the problem, and where we read we can deal with the problem now with our own issue, with our own failure type of blank name. Just before we commit, I noticed that we have an issue still in item, which is that we still have this name string. So let's see if we can get rid of that. We're using that into map. Well, I think we can just use the name at that point and get the value out of it. Or we could use the name and do toString on it. Either work out to be the same thing. And in toLine, which is where we're writing it out, we have the same thing. This, we can just use the name. Run the test to check that's true. And remember, this works because our non-blank string, its toString is just the string inside it. So that means that we can go back to item. This name string is now unused, and run the tests. Okay, commit that. 2 warnings, no doubt imports. And these are places that did use now item creation error, but are now using the stock list loading error. We have one error left constructing items, and that is what happens when we have a negative quality. Well, you can see where this will go. We can create a type like non-blank string that will be non-negative int. Or we could create a type that represents a quality. I can't right now decide which one of those things to do, so I think we will finish this episode here. If you'd like to see the next episode where we finish this refactoring, then please subscribe to the channel, like this video, and if you have liked this, then I think you'll probably like the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thank you for watching.